this actually mean? Okay, so the original, remember we drew the original shape. Okay, I'm going to switch to the other mode now. This is the original shape, right? So this is our original shape, right? So we know that E1 is our aluminum, E2 is our steel. When we replace when the reference material is steel, right? What we have done, okay, I'll show you what we have done. What we have done is we change the entire structure to become steel. I repeat again, we change the entire structure to become what? Steel. So what does this mean? Okay, so this part over here did not change in geometry. Okay, this part over here did not change. This is still what? This is still steel. It did not change. Now we are going to change the aluminum to become steel. Okay, so over here when we pick the reference material is steel, so we are going to replace aluminum with what? Steel. Without adding extra strength. Without adding or losing, okay, losing any strength. So what do I mean by that? Okay, simple. So I replace this now, and now it's 1/3. So what it means is the height, right? You all can see over there. Excuse me. You all can see over there that the height, right, is 4, and the width is 1, 2, 3, 4, 5, 6, 7. The width is 7. Okay. So the height is 4. Okay, so 1, 2, 3, 4. And the width is 7, right? So 7 is, wait, 7 divided by 3 is 2 and 1/3. So what we just did, right, is the height did not change. 2 and 1/3. Okay. So the height did not change. Only the width what? Only the width changes. I repeat again, the height did not change. The width what? Changes. Okay. So this structure over here is equal or equivalent to this geometry steel, and now you replace aluminum with what? Steel, right? So this is very obvious, right? If your structure is made of aluminum, right, you want to replace with steel, you can make it what? Smaller in terms of what? Geometry. But take note, the height is constant. Only the width changes. This is very important. Okay. Now, what if now what does it means by using aluminum as the what? As the reference material. Okay. So again, if this is the same shape, right? So what we have just done, right? What we have just done is aluminum is still the same. So this is our aluminum. and this is our steel, right? So the aluminum is still the same, right? So I'm going to sketch out the aluminum. So the aluminum is still the same, 2,4. Right? Aluminum is still the same. Aluminum did not change. However, we want to replace the steel with aluminum. And what will change is the what? The width. So now, if we replace with aluminum, this is how it looks like. Now this has been replaced with what? Aluminum. And this is also what? Alu. Okay, it makes sense, right? If the top part is steel, you want to change to aluminum without any compromise or in any increase or decrease in strength, you have to increase the geometry. Okay, so something struck to all your mind is, hey, people say to make the car lighter, we have to use what? Aluminum. We have to replace steel with aluminum. But when you do that, you realize what will happen to the geometry of the car to withstand the same load. Your car become wider. Yes or no? Right? So you have to be careful over here, right? Right? No doubt you save weight, but you increase what? You increase in terms of geometry. Okay. So we have to be very cautious whenever we want to replace material. You have to be very cautious. Always remember, true, you reduce weight, but your geometry gets what? Bigger. Okay. So in order to calculate the stresses now, in order to calculate the stresses, it's very straightforward. Okay, so the formula to calculate stresses, so stress X is equal to, depend on what you're looking for, is if it's in the steel portion, you use N steel mz over Izz multiplied by Y. If so, this is in the steel section. Okay, and stress X for the aluminum section, mz over Izz multiplied by Y. So this is for the aluminum. Okay. So not only this change, also finding the second moment of area change. Okay. Now, a very interesting thing you will ask. Okay. I mean, not yet until let me put in another page without all this. The question that we always ask ourselves is this. Okay. I'm not doing the right thing now. Aye. Go on. Oh, it's this one. Sorry. Right. Now we ask ourselves, if we take a look at this diagram, if we look at this diagram only, okay, I'm going to take this diagram over here. Okay. And we look at here, why the width changed only, where the height is held constant. Okay. So why the width change? Okay, where the depth is held constant. This is because of the what? This is due to the calculation of the second moment of area. Right? This is due to the calculation of the second moment of area. So if we look at the calculation of the second moment of area, I is equal to width depth cube over 12 plus by width multiplied by depth. You all know all this formula by now. We only change the width. So remember, only. So this is for homogeneous material or single material. Okay. For composite material, only the what? Width changes. So when we write the formula, right? So I is equal to NW multiplied by D cubed over 12 plus by NW multiplied by D and then Y bar minus small y bar squared. Right? And note Y bar is also what? A constant. Right? Right? So this is correct if the depth or height changes. Okay, let's say and width is held constant, right? The problem is this: now you have n, the width is constant. Now you have n depth cubed over 12 plus by n plus by the width, right? And then n depth, right? This one has no problem. And then this one, your y bar minus y bar squared, you're going to have some issue over here. Because now you're changing the what? You're changing the height, okay? Now, that is one problem. The height is changing over here, which is bad news. The problem with this function over here is this. If I will expand, you basically telling me n or width n cube depth cube over 12 plus by width. As I said, the n and the depth down here is no problem. But the problem is y bar minus small y bar of 2. This one will have issue. So now this becomes what? N cube. Means the proportion you increase by n to the power of 3. And this is wrong. So that is why the correct form, so this is the wrong form. This is the correct form because it did not affect your what? Your depth. Because of the cube over here and your y bar did not change. Okay, so that is why we held the what? We hold the height constant, the depth is changing. Okay, with that, I'm going to stop now. I will see you guys on Thursday.